Hello everyone. This work is entitled Beyond Skin Tone, a multidimensional measure of apparent skin color. My name is William Tong, and this is joint work with Shamek and Alice from Sony AI. Skin color exhibits a large variation, as illustrated by an exhibition from the artist Angelica Das. For example, when considering these two images here in the middle, the lightness is similar, but one tends more towards red, while the other one tends more towards yellow. And this is exactly what we address in this paper by trying to characterize and quantify such variation in skin color. The paper from Joy Buolamwini and Timnit Gebru has initially highlighted bias related to skin tone and its importance in fairness assessment to understand when there are performance discrepancies in commercial models. Since then, the field has come a long way, and now fairness assessment occurs for image datasets as well as generative and discriminative models. In the context of this paper, we illustrate the relevance of our multidimensional skin color scale for all these applications. The current standard to assess skin color is the Fitzpatrick scale, which consists of 6 different categories to characterize the skin tone from light to dark. Interestingly, Fitzpatrick proposed his scale for measuring the sun tanning pathways of Caucasian skin when exposed to sunlight. Over time, this initial scope has expanded to other fields, including fairness evaluation. However, the fact that this initial scope is restricted from the start has several implications. For example, it has been found that the Fitzpatrick scale has limited utility for several ethnic groups, and the annotation process can lead to errors or inconsistency. The challenge is then to develop skin color scales that are more comprehensive of the human skin variation. Let's take a short step back first. So the constitutive skin color is the result of a complex physical, physiological, and also biological phenomenon. One way to characterize the constitutive skin color is through a spectrophotometer to measure the reflectance to different wavelengths. However, this is impractical in a real-world scenario where we would need to collect the spectrophotometric response of thousands of humans. Instead, in our paper, we focus on the apparent skin color, which is the one depicted in images. We propose 2 scalar scores for characterizing the skin color. The first one is the perceptual lightness to characterize the skin tone from light to dark. And the second one is the hue angle to characterize the skin hue from red to yellow. Both belong to the CIE-LAB color space, which has been shown to correlate well with human perception of color. We leverage our multidimensional scale for apparent skin color on different use cases. First, we show the distribution of skin color within existing datasets, such as the FFHQ dataset, where we observe that light red skin are overrepresented and dark yellow skin underrepresented. Second, we assess existing generative models trained on FFHQ and observe that they actually replicate or even amplify dataset biases. Third, we manipulate the skin color in images to assess its causal effect in classification models. And we observe that the light skin tone appears more feminine, or that the light skin tone or red hue appear more smiley. For more use cases, feel free to check our paper. To wrap up, our paper is a first step towards more comprehensive skin color scales for fairness assessment in computer vision. We have proposed 2 scalar scores, the perceptual lightness and the hue angle, to measure skin color quantitatively in images. This has helped to reveal data, but also model biases that were previously invisible. And in the future, we envision that other human-centric tasks would benefit from characterizing both the skin tone and skin hue for the apparent skin color. Still, characterizing the apparent skin color remains very challenging, as there are open questions on how to consider, for example, external factors that modify the skin appearance. This concludes my presentation. Thank you for listening.